Welcome to our lesson on how to use Punnett squares. Today we are going to be using our knowledge of dominant traits, recessive traits, genotypes, and phenotypes to predict the odds that offspring will be inheriting certain traits from their parents. To do this, we will be using a tool called Punnett squares. Before we begin, be sure that you have downloaded the worksheet that goes along with this PowerPoint. As we progress through the slideshow, I will be informing you which sections to fill out. Some you will fill out with me, some you will fill out on your own. At these points where it is your turn to fill out your worksheet, I will signal for you to pause the slideshow so that you have time to fill out the appropriate sections. Once you've completed the presentation and worksheet, you'll be adding it to your notebook on OneNote for points. Throughout most of the slideshow, I will be demonstrating how to complete each step, even though some of this information should hopefully be reviewed for you. In my demonstrations, I will be using example 1 from your worksheet that you should have downloaded. Examples 2 through 4 will be the problems you work on by yourself throughout the presentations. So make sure you're filling everything out as instructed. I will be sure to remind you as we go through this presentation. Alright, so here is some information that we have definitely seen before. Remember that we said that all Mendelian traits have a dominant version and a recessive version. The dominant version will always cover up the recessive version if it is present. So, if we have a dominant allele with an recessive allele, and the dominant trait is going to be what shows through. So it's going to cover up that recessive trait. So here's our example 1 from our worksheet that you should have. So make sure it's in front of you so that you can see it. It says that in dogs, the gene for fur color has 2 alleles. The dominant allele, big F, codes for gray fur, and the recessive allele, little f, codes for black fur. You have a female dog that is heterozygous and a male dog that is homozygous. So our first step is that we're going to take when we're solving a Punnett square is to determine what the dominant trait and the recessive trait are in the scenario. So we're just going to use a little information that we've been given here. In most cases, the problem is going to tell you flat out what's dominant and what's recessive. So this should be a pretty easy part of starting our Punnett square. So in this case, it says that gray fur is what is dominant and black fur is what is recessive. As you can see in the pictures here, we have gray dogs dominant and black is recessive. And please be sure that you are filling this out on section A of example 1 on your worksheet. So tell me which is the dominant trait and which is recessive. Now it's your turn. I will signal you when it is your turn to fill out any section on your own as practice with a slideshow that looks like this one. During this time, it would be best for you to probably pause the slideshow and make sure that you're filling out the appropriate sections before continuing. That way you're not feeling like you're rushed as we're going through. So make sure you pause it so that you have time to work on that so you don't miss any new information. So go ahead and fill out step A on examples 2 through 4 by telling me which trait is dominant and which trait is recessive for each scenario. Once you are done, continue on with the presentation. The next step we have to take is to identify what our parents' genotypes and phenotypes are. This should hopefully be a pretty easy task because we have learned all about genotypes and phenotypes before. In some situations for Punnett squares, the problem will give you the phenotype or a description of the genotype, such as heterozygous, and you have to find the genotype of that parent. So you're given the phenotype, and you need to know what the genotype is. So remember, first off, we've gone over this before, but just as review, we have 3 different types of genotypes. We have homozygous dominant, which means that we have 2 dominant alleles in our genotype, We have homozygous recessive, which means we have 2 recessive alleles inside the genotype. Remember, homozygous means the same. And then you can also be heterozygous, which means different. So we have 1 dominant allele and 1 recessive allele in that genotype. So let's look at our example that we've got here. This is still example 1 from your worksheet. It says that our female is heterozygous and our male is homozygous recessive. So that means that mom has 1 of each type of allele. She's heterozygous. And that makes her gray because the dominant allele is going to stand out over the recessive. So mom's genotype is heterozygous, so she has a big G and she has a little g. Dad has 2 recessive alleles because he's homozygous recessive, so he has 2 of the same and they're both recessive. And that makes him black because he only has recessive alleles, so he's going to show the recessive trait. So dad has a little g and a little g because he's homozygous recessive. Please be sure that you are filling this out on step B of example 1 on your sheet. Again, now it is your turn. Fill out step B on example 2 only by telling me what the parent genotypes are based on their phenotypes. Be sure to pause the slideshow while you work and then continue on once you've completed this. So continuing on with identifying parent genotypes and phenotypes. In some problems, you will be given the parent genotype and you have to find the phenotype, so the opposite of what we just did. This is honestly a lot easier process, so this one shouldn't hopefully be too hard to understand for you. So let's look at the example I provided, which is actually example 3 from your worksheet. This is the only time I'm going to use example 3 on my presentation, but it had the type of information we needed. So rather than example 1, you're going to fill out example 3 with me on this slide only. So example 3 says, in humans, tongue rolling is a dominant trait. So rolling your tongue like a taco, that's a dominant trait. Not being able to roll your tongue is a recessive trait. So we have a female with a genotype of big R, little r, and a male also with a genotype of big R, little r. So that means that our mom and our dad both have a heterozygous genotype, so they have one of each type of allele. This means they will show the dominant trait. Remember, the dominant will cover up the recessive, so they will be able to roll their tongues because that is the dominant trait. So we have two parents that are both tongue rollers. So be sure you fill out that on your step B of example 3. That is what we're doing right now. So tell me what mom's phenotype is and what dad's is. Alright, now it is your turn. You're going to be filling out step B on example 4 only. That's the only step B we have left. So fill out the phenotypes of the parents on example 4 on step B, and then be sure to pause so you have time to do that, and then continue the show once you are done with that section. Okay, so the next step is something new that we have not done yet in this class. We have worked with all the traits, we have worked with genotypes and phenotypes. Now we're going to be learning how to actually use the process of filling out the Punnett square. So if you were writing this out on paper, you may have to draw the square yourself. But because we are online in this case and I gave you the worksheet, I've drawn it out for you by making a big square with 4 little squares inside. So it's not too hard to draw even if you did have to do it on your own. After it is drawn, you must write your parents' genotypes on the sides of the squares with mom's genotype on top and dad's on the left side. I'll show you what I mean on the next slide with our example. So we have already figured out in example 1, we're back to example 1, that mom has a genotype of big F, little f, and dad has a genotype of little f, little f. Let's start by writing mom's genotype on the top of the square. So here's the square that we have. It's just a big square with 4 little squares inside of it. You're going to write one allele, and we're doing mom, so we're looking at the top of the square. You're going to write one allele over the first column, and you're going to write the second allele over the second column. So just like it appeared on the slide, we have mom's first allele, which is a big F, over the first column, and then her second allele is little f, it's over the second column. Okay, so let's go ahead and do dad's genotype. So it's the same exact idea, but now we're just doing it on the left side of the square. So you're going to write the first allele by the first row, which in his case is little f, and then his second allele is going to be by the second row, which again is little f in this situation. So each of the 4 parent alleles should have their own row or column that they're in charge of in a way. So they each have their own row and column. Mom's being the columns and dad's going to be the rows. But now we have both parent genotypes written in the proper places, so we're going to be able to fill out our square in our next step. So be sure that you're filling this out on example 1, step C. Make sure you fill in those parent genotypes on the square that's provided. Alright, now it's your turn. Complete step C on examples 2 through 4 by putting those genotypes that you found previously on the correct spot on the Punnett square. Once you're done pausing the presentation, make sure you go ahead and continue the slideshow to figure out what we're doing next. Alright, we're getting really close to done here, guys. Our next step is to actually fill out the Punnett square. The way we do this is by taking one allele from each parent and making all the possible combinations of genotypes for our offspring. There will be 4 offspring genotypes written when you are done. Some of those 4 genotypes could be the same, some would be different. It's just going to depend on the problem that you are completing. So let's look at our example 1 on next slide. So we already put our parent genotypes in the correct place. So I just left them there on that slide so that you could see that. We wrote them mom on top, we wrote dad's on the left side. Now what you're going to do is find the combinations of genotypes and match them up in a way, which sounds a little confusing, but let me show you what I mean by that. If you take mom's first allele, which is the big F, and I'm drawing an arrow where you're moving it to in a way where you're going to match them up, and you take dad's first allele, which is a little f, so I'm showing you where you're going to match them, which is in the top left square, and you put those two together and combine them to make a genotype, you're going to get a genotype of big F, little f. So you can see that you brought mom's down to the top left square, dad's over to the top left square, and you combine them and you get a big F, little f. So this is the process you use for all squares to fill out. You're going to drag one of mom's alleles and one of dad's alleles over to combine them. So let's go ahead and do another one. And I color coded these with the arrows and the box just to make sure you see where everything's going. So let's look at mom's second allele. So if we take mom's second allele, and I have a red arrow there pointing to the top the top right box, and you take dad's first allele and drag it over to the top right box. If you put them together, we have 2 little f's, so our genotype there is going to be little f, little f. And hopefully that makes sense. Let's go ahead and do the next one to show you what I mean. So we'll fill out the bottom left box this time. So you have mom's first allele, which is big F, and we're going to have a blue arrow coming down. And we have dad's second allele, which is little f, mom's first allele, dad's second allele. Coming to this box, and when you put them together, we bring down a big F and a little f, and we get big F, little f in that box. And then we're going to do our last box, which is mom's second allele, which is little f, so in a yellow arrow, bring it down. And then dad's second allele is brought over to that box. So we have a little f from mom, a little f from dad. That means we have a little f genotype possibility for the baby. So as you can see, we're just taking the allele from mom and bringing it down either 1 square or 2 squares, the allele from dad and bringing it down or bringing it over either 1 square or 2 squares depending on which ones we're matching up, and combining those 2 alleles to make a possible genotype for the baby. So now you've got all of your Punnett square filled out, and these are your 4 possible genotype combinations that you could have if you have these parents. So make sure you fill out that Punnett square on step D for example 1. Fill that out so that you have that information to go off of. Alright, now it is your turn. Fill out step D on examples 2 through 4 by filling out your Punnett squares. You already have the parent genotypes written in, so you should be able to just fill out that Punnett square with those by using the method we used before. So be sure to pause your slideshow so you have plenty of time to work. This is probably our longest step, one of the longest that definitely so far that we've done. And then, come back to the presentation when you're ready to move on to the next step. Alright, this is our very last step. So we've completed the Punnett square. Now we just have to use the information that the Punnett square is giving us. If we completed it without using the information, it'd be pretty pointless. So now we're going to look at what all of this means. This information that we have is going to help us predict what the chances are of our baby having each possible genotype and phenotype there is for that trait. So we will be calculating the percent chance and the overall ratio for genotypes and phenotypes. So let's look at our example 1 on the next slide. So we've completed our square. I have it up on the slide there for you to look at. We now need to look at what genotypes are there in the square that we have for our offspring. For example, how many genotypes of big F do we have out of the 4? We can see there's no possible combination of big F there. So that means we have a 0% chance of the offspring having a big F genotype. There are no big F's in that Punnett square whatsoever. What about big F, little f? if you look, we can see that we have 2 big F little f's out of the 4 that we have. So that means 2 out of 4 is half. So that means we have a 50% chance of our baby being big F little f with this genotype. And then our last possible genotype is our homozygous recessive. So if we look at little f, we can also see that it's a 50% chance because we have 2 out of the 4. That means half, so we have 50% chance. So we have a 0% chance of being big F, a 50% chance of being big F, and a 50% chance of being little f. So now that we have the information, we're going to write an overall genotypic ratio. So a ratio that shows how much of each genotype do we have compared to each other. So if we write this out, we know that we have 0 big F's, we had 2 big F little f's, and we had 2 little f's. So if you write it out, originally it'd be 0 to 2 to 2 because we have 2 and 2, but we can reduce this down to 0 to 1 to 1. So now we have found all of our genotype probabilities, when we can use this information to help us find the phenotype probabilities. So we know that big F, and big F, little f will show the dominant trait because dominant allele covers up the recessive allele. In this case, that dominant trait is gray fur. And we know that little f is going to be the genotype that shows the recessive trait, which in this case is black fur. So we have 0 big F's, and we have 2 big F little f's. So out of 4, we have 2 possible offspring genotypes that are going to show us the dominant trait. So 2 out of 4 means that we have a 50% chance of that baby dog being gray, because 50% chance of showing the dominant trait. We then have 2 little f's, which we know is showing the recessive trait. So we have a 2 out of 4 chance that the offspring will show recessive, which means that there's 50% chance of that dog being black. So we're just using our knowledge of what's dominant and recessive in this trait situation, and we're transferring over based on what genotypes we have. Make sure that all your percentages are adding up to 100%, no matter if you're working with phenotypes or genotypes. It's got to add up to a whole. So we have 50% chance of gray, 50% chance of black. That adds up to 100. For the genotypes, we had 0, 50, and 50. It still adds up to 100. So no matter if you're looking at 3 different genotypes or 2 different phenotypes, you still need to make sure it only adds up to 100 because that's a whole for us. Now we can lastly do our phenotypic ratio. So we have 2 gray dogs and 2 black dogs, which if we put 2 to 2, it can then reduce down to 1 to 1. So we have a 1 to 1 chance of being gray to black. So there's an even chance of those baby dogs with those 2 specific parents of being gray or being black. So make sure you filled all of this out in the example on step C. Or sorry, excuse me, step E. Example 1, step E. My apologies. Alright, now it is your turn to finish your problem. We are officially on our very last step on finishing how to fill out and read a Punnett square. So complete step E on examples 2 through 4 by finding the genotype and the phenotype probabilities. When you are done, especially if you feel like you struggle with some of the steps, please take a look back at the key and checklist that I posted in the content folder so that you compare your worksheet answers to mine. Honestly, even if you didn't feel like you struggled, it'd still probably be a good idea to do just to make sure you're on the right path. So please make sure you look at that. If you find that answers don't match, go back through the slideshow, check your work, see where you misstepped. And if you're still struggling, feel free to get a hold of me. So call me, email me, and we'll make sure that we're catching where you were making a mistake. So once you are done, please be sure to submit your filled out worksheet to your notebook on OneNote by the weekly deadline so that you can get the points for your notes and activity participation.